part 2. After you've graphed that, okay, we'll take a look at that in class. Actually, should just be this. We should go down 1, left 1, down 2. So that should be our vector. Now, the cool thing about these, if let's say we have 2 vectors, like let's say we still have this 2i or 3i plus 2j, and vector w for where now is, let's say, this negative I plus 2j. Let's say I want to get 2v minus w. It's the same idea. Now this is even easier to do. We go 2 times 3i plus 2j minus, be careful of the signs, negative I plus 2j, and I distribute 6i plus 4j minus or plus I minus 2j. Whoop, that should be a j there. And I just combine my like terms. We get 7i plus 2j. And there's our new vector. And we can even graph this one. Where is it at? What's its length? What direction is it heading? This right here tells us everything. We know where, if we can find an initial spot, we can find out where it terminates. We can find out how long it is, which we're going to talk about next. We can find out the direction it's handling, which we're going to talk about a little bit today, but mainly tomorrow. Okay? Very cool stuff you can do with vectors. All right. So, how do we find length? It's called magnitude. Okay, how do you find length of a vector? Well, a vector, remember, it has direction. It has an change in x, and it has a change in y. It doesn't matter if you write it in component form or in the standard form. It would still be some change in x in the I plus some change in y in the j direction. It's still the same. When you draw it out, no matter where you start from your initial, if you go to your terminal point, we have a change in x, we have a change in y. Well, how can I find out this length right here? Very simple. Pythagorean. Okay, the Pythagorean Theorem. So, now, how we identify magnitude is the following. It is double absolute value. Okay? And all it is it is the square root of the change in your x direction squared plus the change in your y direction squared. Now, be careful. This comes from the Pythagorean Theorem because it's very simple. Equals the length of our vector squared. Very easy to do. Okay? So if I want to find the... Matter of fact, I don't even memorize the formula, just know Pythagorean Theorem. If you can see me just shaking my head like, duh. So if I want to find the magnitude of this vector, graph it. Graph it like it's hot. 4 in the x, that's our delta x. Up 3, there's our delta y. 1, 2, 3, 4. 1, 2, 3. There's our terminal point. We're starting at 0. So there's my vector. How do I find its magnitude? Equals the square root of, well, this is 4 and 3, so it's going to be the square root of 4 squared plus 3 squared, which is the square root of, what's that, 16 plus 9. Please don't do 4 plus 3. That is square root of 25, which is 5. Its magnitude is 5. That's its length. Matter of fact, let's go ahead and try number 2. Ready? Graph it like it's hot. Graph it like it's hot. I do it up here because I go negative. Oh, should have done better than that. Negative 2 of 5. And let me graph it up here. 1, 2, 3, 4, 5. There's my graph. If I want to find the magnitude of the vector, just use Pythagorean Theorem if you need to. Magnitude. It's a triangle, right triangle. Here's 2, here's 5, left 2, up 5. If I want to find its magnitude, it's going to become just Pythagorean Theorem. Take 2 squared plus 5 squared, and I have to take the square root of it. That's a 5. So this becomes the square root of 4 plus 25, which is just the square root of 29. Positive. Magnitude is always positive because it's a length. Always positive. It's a length. Therefore, positive. Has to be positive. And even if I do it in the component form, not component form, the standard form, this is a 1, right? There's my delta x. There's my delta y. There's my change in x. There's my change in y. Doesn't matter where I start. If I start at the origin, easy. It says to go right 1, down 3. There is my vector. Think right triangles. 1, 3. How do I find its magnitude? Very simple. It's going to be Pythagorean Theorem. 1 squared plus 3 squared. So 1 squared plus 3 squared. Even though it's negative, it's still going to be positive because I'm squaring it. But then we got to take the square root. So we get the square root of 10. That's how long that vector is. How long is the vector? Root 10. Very easy to do. Now tomorrow we're going to spend some more time dealing with direction of a vector. We're going to take a little bit of it today in just a few moments, but that's mainly tomorrow how we define direction of a vector. It involves a little bit of trig. But right now let's find out how to find a unit vector. Now, unit vectors are very important. We already talked about the standard unit vector, but what is a unit vector? Well, a unit vector is how long a vector is, is a vector that travels in the same direction as an original vector, but only has a length of 1. So let's say we have the vector, okay? We have some vector here. Starts here at some initial point, and it terminates over here. I can find its magnitude. There's vector v. The magnitude, we already said, is just the double absolute value. Correct? Well, remember, this is going to give me some length. This will be some delta x. This will be some delta y. Now, I don't memorize formulas by any means, but the original vector is just this. It's some change in x, some change in y. Each one of these is an individual length. Length in the x, length in the y. I want these lengths to be 1. So how do I get them to be 1? That's right. I divide by its total length, the magnitude. So therefore, a unit vector is the same. It's going to be your change in x divided by its total length. The change in y over its total length. I don't memorize it. I just derive it every time. It's very easy to do. So let's take a look at a couple here. Number 1. Let u be the vector 3, 4. Let's find the unit vector. Okay? So the first thing we need is its magnitude. Now hopefully by now you kind of came up with a shortcut. There is my delta x. There is my delta y. It's just Pythagorean Theorem. The magnitude of u equals 3 squared plus 4 squared. Take the square root, so we get 5. That's the length. So to get the unit vector of u, unit u, unit, we're going to take the original vector, which is 3, and divide it by its magnitude. Take the original vector, divide it by its magnitude. Now, this is very easy to prove, okay? That is going to be 1. Use Pythagorean Theorem. If I take 3/4 squared plus 3/5 squared plus 4/5n squared, and then take the square root, we should get 1. Okay? So this becomes 9/25 plus 16/25, which is 25/25, which is 1. Square root of 1 is 1. So its length is 1. This is called a unit vector. Try number 2 real quickly, pause it, and we're going to go ahead and do number 3 together real fast. Okay? Number 3, same idea. I have to get the original vector. I have to get its magnitude. Again, pretty easy to do. Vector w, its magnitude. We're going to take this negative 2 and square it plus 5 and square it, and then take the square root. All that's from the Pythagorean Theorem from up above. So this becomes the square root of 4 plus 25, so it's the square root of 29. So to get the unit vector of W, we're going to take the original, -2, whoops, sorry, I guess I should write it this way, -2 over root 29 in the I direction, plus 5 over root 29 in the J direction. Very easy to do, even in our standard unit vector form. All right, so our next one, our last one, before we actually have 3 sections today. I do apologize for that. Make sure you go all over 3 to find the vector in the same magnitude. Okay, so this is pretty easy to do also. We just want to find, this is going to deal with a little bit about direction here. Okay, so to get direction, very simple, I'm going to graph this. My vector, U. It says to go right 2, up 5. And basically to get direction, it's simple. Okay? I want to find this original length that I don't know what it is. I can use Pythagorean Theorem, but I want the actual distance to be 6. So I'm going to kind of get the vector. Now to get the vector is like direction. Very simple to do. So the point here, I'm going to find out where this terminates at. And it's kind of easy. This is 2. This is 5, and using Pythagorean, this is the square root of 29. So I want to find out where this point is located. So if I think trigonometry, this is just the cosine of the angle, which is just adjacent over hypotenuse, 2 over the square root of 29. Its sine value, which is the y value, is 5 over the square root of 29. So I want this now to be a length of 6. So my vector, my original vector, U, as a vector, U as a vector is 2 over the square root of 29, 5 over the square root of 29. Well, to get vector V, I take U, I just multiply by 6. 2 over the square root of 29, 5 over the square root of 29. And it's okay to leave it like this, or you can distribute it. We get 12 over the square root of 29 and 30 over the square root of, whoa, where did 2 come from? I don't know, square root of 29. And there's our answer. All right, go on to part 3. Go and try the back if you can. If not, go on to part 3 and we'll take a look there. This will take about 2 minutes.